On this page here, this is all review of ways that we've prepared carboxylic acids. Since the carboxylic acid is carbon's highest oxidation state in an organic compound anyway, we have oxidative reactions on this page that can be used to prepare a carboxylic acid. So if I have any kind of toluene, whether it's substituted or whatever, strong oxidizing conditions, in this case potassium permanganate in almost boiling water, oxidizes at the carbon that's attached to the benzene ring, so on a benzyl carbon. So we can go from paranitrotoluene to paranitrobenzoic acid with pretty good yield here. If we do oxidative cleavage of an alkene, remember that snips the double bond right in half, and if we do it under potassium permanganate conditions, we end up with carboxylic acids if we had a mono-substituted side of a double bond. Compare this with ozonolysis, O3 and zinc. Step 2, instead of the carboxylic acids, that will give aldehydes in this case. Since this was just a double bond with one R group on each carbon. In other words, there was an H on each carbon. So ozone just snips it and makes it into a carbonyl. Potassium permanganate oxidizes those further to carboxylic acids. Likewise, if we have a strong oxidizing agent with an alcohol or an aldehyde, we can fully oxidize it. So CrO3, right? Chromium 6 oxide is the strongest oxidizing agent for alcohols and aldehydes that brings them up to the carboxylic acid state. Recall that if I have a primary alcohol, we can do PCC, pyridinium chlorochromate, to make an aldehyde, and that aldehyde then can be further oxidized to the carboxylic acid. Okay. No need to do it in 2 steps if you want the carboxylic acid, but in case you want to stop at the aldehyde, you need PCC to do that. One new reaction in this chapter, but not really, since it's the mechanism we've been studying for weeks now, is that if we have any Grignard reagent, so any kind of alkyl or aryl or vinyl magnesium bromide like this, all we need to do is react it with carbon dioxide, with CO2 gas, right? Got a Grignard reagent, we just bubble CO2 gas right through it. Okay? The carbon that acts like the C-, okay, attacks the carbon of CO2, kicking a pair of electrons up onto one of the oxygens, making a carboxylate. This is magnesium bromide benzoate. And then the normal acidic workup that we normally do after a Grignard reaction gives us benzoic acid. So I can just show you this, how this would be useful in one type of synthesis. Here's our starting material, right? Cyclohexene. Through a number of steps, we can convert that to 2-hydroxy cyclohexane carboxylic acid. So I have a cyclohexane with a C double bond OH group attached to one and a OH group attached to the next one. So maybe if you want a little practice doing multi-step synthesis, this one does require the use of a protecting group. If you're doing it at least the way that I'm thinking, there might be another way. So pause me if you want to practice this. Start with the product right here. Think about what can be used to make that, especially considering what we just talked about. Going backwards retrosynthetically, I could imagine doing a Grignard reaction. But the thing is, I can't have an OH group in the same molecule that I have a Grignard reagent, otherwise it'll just deprotonate the OH, so I have to have a protected alcohol. So remember we use TMS, trimethylsilyl, as a protecting group for alcohols. Going back, before we protected and before we made the Grignard, we can have a bromohydrin, which we can make in one step from our starting material. So let's go forward here. Cyclohexene Br2 in the presence of water makes a bromohydrin, so Br next to OH. It does that by way of a 3-membered ring with bromine with Br plus in it, and then water attacks it and then is deprotonated. So it opens up the Br ring and gives you an OH. If you want to do it specifically with things from our last few semesters, you can make an epoxide and then open it with HBr. So here's our bromohydrin. Let's protect the alcohol. So here I'll write both of these. Let's do TMS chloride with some sort of base, R3N. Okay. That turns the OH into OTMS. Let's do magnesium then. Magnesium metal makes the Grignard reagent. So MgBr, OTMS. If you fail to do that protecting group, the Grignard reagent will not be reactive. You'll actually end up with this, OMgBr. And H is there. So we don't want that. So that's why we need the protecting group. Then we can do the Grignard reaction that we just talked about. Step 1. Well, here, let's just write that. CO2. I'll show you the carboxylate here. C double bond O. O. Okay. Along with alcohol still protected, then aqueous acid does two things. It'll protonate the carboxylic acid and deprotect the alcohol, giving us our product. Ta-da. I would expect a multi-step synthesis about of that difficulty to be on the exam. Right? 1, 2, maybe 3 or 4 major steps like that. Okay.